Now we are going to find the solution of differential equation at x equal to x0, where x0 is an ordinary point. So the way that we do, we just assume that y is equal to summation n is equal to 0 to infinity of an times x minus x0 to the power n. Let's take a look at the example. The problem statement asking you to find the solution of this differential equation around x equal to 0. So that means x0 is equal to 0. And find a solution which is satisfied with these two boundary conditions. Okay. So now your solution wouldn't have the constant number there, because you put that constant as a number because they give you the boundary condition. So the way to do, of course, you get the check that your x0 is the ordinary point or singular point. If it is the ordinary point, you can assume like this. But if it is a singular point, no way to do because you haven't learned it, you just can't do anything. Okay. So in order to define whether x equal to 0 is the ordinary or singular point, you've got to rearrange your differential equation in such a way that the coefficient of the second derivative of y is equal to 1. From doing that, you would get px is equal to 3x divided by x squared minus 1 and qx is equal to x divided by x squared minus 1. And from your qx and px, you would find that x is equal to minus 1 and 1 will make px and qx is not be an analytical function. So that means x equal to 1 and minus 1 are singular points. So the other value of x would be ordinary point. So in this case, they're asking you to find the solution at x equal to 0. X equal to 0 is a singular or ordinary point. X equal to 0 is a singular or ordinary point. It's an ordinary point, right? Because singular you have only minus 1 and 1. Okay. So by this, you can find the solution by assume y is equal to summation of n equal to 0 to infinity of an times x minus x0 to the power n. But since x0 is equal to 0, so you would get an times x to the power n. And then the next step is just that plug the y, the function y that you zoom back into your differential equation. But in your differential equation, you have second derivative and first derivative of y. So you've got to do the first and second derivative of your y. So you would get this. And after you do the first and second derivative, then you plug the term of second derivative, first derivative, and y into your differential equation. You would get this one. And then from this, just use mathematics to combine the terms together. This one, I just, how to do it? You have x to the power 2 here. You times with this term. You would get x to the power 2 summation of an times n, x to the power n minus 1 times x to the n minus 2. But x to the power 2 and x to the power of n minus 2, you combine them, you would get x to the power n. That's why it's coming this term. And minus this term, right? You just times this term with x to the power 2 and this term with minus 1. And this term, the first term, x to the power 2 combined with x to the power of n minus 2, you would get x to the power n. But the second term, you don't have x, so you would get the same x to the power of n minus 2. And this term, you have x here moves to the x to the power of n minus 1. You would get x to the power n. And the last term, you have x there times summation of an x to the power n. X here combine with x to the power n, you would get x to the power n plus 1. Okay, now we are in this line. And then, what are we going to do next? Just that n minus 1, n minus 2. Oh, these two terms, if you can see, this one and that one. N is starting from 0. This one n starting from 0. You have x to the power n here and x to the power n there. So these two terms you can put them together, right? Because each term they are the same. You can combine them together. So you get, we have an and n which is the same. Take it out. So inside we have n minus 1 and plus 3. Okay, you see, you have an and an and x to the power n. So you take them out. Here, take them out, n, x to the power n. So inside we have n minus 1 plus 3. But the rest of the term is just still the same. Now, if you take a look at this, you just cannot combine them together because although n starts from 0, the same, but the power of x in each term are different. So now we are going to shift we are going to make n to be n minus 2. Okay, we are going to put every n here become n minus 2. So the first term, we've got to replace n with n minus 2, right? And the third term, you've got to replace n with n minus 3, right? Okay. The first term, we put n is equal to n minus 2. We would get n minus 2 equal to 0 down here. And this n is n minus 2, minus 3, and plus 1. And this n is n minus 2. an become an minus 2 and x to the power of n minus 2. The second term, we didn't do anything. The third term, we put n is equal to n minus 3. So we get n minus 3 equal to 0 of an minus 3 times x to the power of n minus 3 plus 1 equal to 0. Now, we're about to have all the terms. This one, n minus 2 minus 1 is minus 3 plus 3 equal to n. Okay? And this n minus 2 is equal to 0, so n starting from 2. This term, we didn't do anything. And this term, n minus 3 equal to 0, so n is equal to 3. And so on. Now, we still cannot combine them together because although we have x to the power of n minus 2 for all three terms, but the first term is begin at n equal to 2. The second term is starting from n is equal to 0, and the last term is starting from n is equal to 3. The way that we can do is just that we are going to put 2 into the first equation in order to make this term starting from n equal to 3. So we put n is equal to 2 in there. 2 times 2 minus 2 equal to 0. So I put 0 there. And now I put the summation starting from 3 until infinity of the same term. This one is starting from 0. We are going to make it starting from n equal to 3. So you put the value of n equal to 0 there, you get 0. You put the terms of n equal to 1 there, 0. You put n is equal to 2 there, you got a2 times 2, right? X to the power 0. and plus the rest of the term. Since we have negative sign up here, so I put negative sign there. Summation of n starting from 3 to infinity of an times n minus 1 times x to the power of n minus 2. And the last term we didn't do anything because it's already starting from 3. Okay. So we do rearrange in such a way that we can easy to observe. And then we would get minus 2a2 plus, now these three terms you can combine them together. You got summation n starting from 3 to infinity. You have x to the power of n minus 2, the same, take it out. And then the first term you got n times n minus 2 times an minus 2. And the second term you get minus an times n minus 1. And the third term you got plus an minus 3. And then we do the comparing the coefficients. For the x is equal to 0, you got minus 2a equal to 0, so a2 is equal to 0. And for the x to the power of n minus 2, you got the term inside the parentheses equal to 0. So you got the, what you call, recurrent relation, relation. From that I would get an is equal to n times n minus 2 times an minus 2 plus an minus 3 divided by n times n minus 1. But this one you can use when n is greater than, equal or greater than 3. Why do we know that? Because our summation starting from 3 to infinity. So this one you got to put n is 3 or greater than 3. And then, because you want to know the root term of an. So you got to put the value of n equal to 3, 4, 5, 6, 7 in order to see is there any root term for that. So if put n is equal to 3, I would get a0 divided by 6 plus a1 divided by 2. I don't see any root term yet. And then I put n is equal to 4, I would get, the value of a2, right? a2 is equal to 0, so I would get a1 divided by 12. a5 is 4 over 3a3 because a2 is equal to 0. And then a3 is a function of a0 and a1, so you just put it there. It's not a root term, so that's fine. You just put the number in there. And you do the same thing so on by plugging the number. But now we know that it's not following as a root term, so that's fine. So the way that you answer this one is just by using the summation of a1, using the summation of an times x to the power n, and then you distribute the term there. And then you plus the value of a in there. You know a0 and a1. You don't know the value, that's fine. You just put a0 and a1. But your a3 is in the form of a0 and a1. You just put there. And a4 is in the form of a1, and a5 is a0 and a1, and so on. And then you put term which has a0 together and a1 together. Okay, now this is the solution, that's it. If you cannot write down in the function, that's fine, because you just want to know the solution of it. Sometimes it's not becoming a function, it's okay. But the thing is that the problem statement is not end with that. It's just asking you to find the solution which is satisfied with two boundaries. And the first boundary is say that at x is equal to 0, y is equal to 4. So you just put in there at x equal to 0, so you got a0. right? This term is equal to 0 because you have x there, right? So you got a0 equal to 4 with first boundary. But for second boundary, it's asking you to do differential of your solution y. Just do the differential. You would say that the first derivative of y is equal to, this term equal to 0. This term is equal to 3 over 6 times x squared, which is 1 over 2x squared. This term is 5 over 8x to the power 4, and so on. For the back, for the second term, you would get a1 times. The first derivative is 1. The second derivative is 3 over 2x squared. And 4 over 12, which is 1 over 3x to the power 3, and so on. And then you plug the boundary, the second boundary there. The second boundary is saying that at x equal to 0, y is equal to, the first derivative of y is equal to 6. So you've got 6 there. Here, because x equal to 0, so the rest of the term you have x and the power of x. So the first term would always be 0. But the second term, you got a1, 1 here, and the rest of the term equal to 0. So from that, you got a1 is equal to 6. So the solution which is satisfied with our boundary condition, the first two boundary condition, is y is equal to 4 times the first term plus 6 times the second term, and that's it. It doesn't mean that you need to get function which is related to be some function that you know.